Okay, so today we're working on objective 2.2b. The topic for today is writing linear equations. And our essential questions are, what info is needed to write an equation of a line? And then the second thing we're going to talk about today is how can you tell if the equation represents, I'll get a pencil there to indicate that it's supposed to say represents. And then we have the symbol here for parallel, or the symbol for perpendicular. So parallel or perpendicular lines. So if you wanted to, you could make yourself a little note that two lines like this say parallel, and then that symbol says perpendicular. Okay, all right. So some things, this is just reminders, just things from back in Algebra 1 that are really critical in pre-calc and calc. So let's just talk about the different forms of the equation of a line. You have slope-intercept form. We've already talked about that this week. Y equals mx plus b. Okay, standard form is ax plus by equals c. You also have general form that I didn't write down here, but general form is a form of the standard form except that it equals 0. So it looks like this, ax plus by plus c equals 0. That's the general form, but we won't be working with that one. Function notation looks just like slope-intercept because any equation that's set equal to y can be written as a function. So f of x is equal to mx plus b. That's just the, let me get an x in there, mx plus b. That's function notation. Point slope. Point slope I like a lot because sometimes you're given a point that's not a y-intercept, and point slope is just a great equation. So it is y minus y sub 1 equals the slope m times x minus x sub 1, and you put a quantity around those two values. That's point slope. Okay, so what information is needed to write the equation of a line? Let's answer this question. The first thing you need is a slope. Well, a point and the slope. That's what you need. You need a point and the slope. That's what you need to write the equation of a line. So sometimes that information is given to you. Sometimes you have to find it. So typically, if you have to find the slope, you will have been given 2 points, whether those points are just given to you or you're looking at a graph and you're using 2 points on the graph. All right, so remember, to write the equation of a line, you need a point and you need the slope. So you just look at the information that you're provided and you decide which form of the linear equation should you start with. So let's look at example 1. It says the line has a slope, okay, I need that, of negative 7/9 and a y-intercept of 0.16. So there's your y-intercept, right? So that's slope-intercept. Find the equation of the line. Well, I have a point and I have a slope. And since my point is the y-intercept, and I know that because my x equals 0, I can go straight into slope-intercept form because my slope is negative 7/9 and my y-intercept, or my b, is 16. That's this value right here. So I can go straight into slope-intercept. Y equals negative 7/9 x plus 16. And there's your equation. Of course, you can also write it in function notation. If you were going to put it in standard form, just as a side note, you can rearrange this equation so that it's in standard form. But there is one caveat for standard form. Standard form has 0 fractions. All of your A, B, and C are going to be integers. So if I were to convert this to standard form, which I could possibly ask you to do, the first thing I'd like you to do is get rid of the 9 in the denominator. To do that, we're just going to multiply everything times 9. So I would write that as 9y equals negative 7x plus, 16 times 9. I forgot what that was. So 6 times 9 is 54. Carry the 1. 9 times 1 is 9 plus 1 is 1, so that's 104. Okay, I'm going to double check that because I did that math in my head and I would be really embarrassed if I couldn't do that in my head. 144. So that's really bad because I had to carry the 5, not the 1. So 16 times 9 is 144. All right, and then if I just wanted to put that in standard form, I just need to move the x to the other side. So the first thing I did was I got rid of the 9 by multiplying each term in the equation by 9, and that cleared the 9 from the denominator. And now I'm just going to move this. I'm going to add 7x to the other side, so this would be 7x plus 9y equals 144. And that would be your standard form of the equation if I were to ask you about it. So just remember, a little side note, standard form, your A, B, and C have to be integers, which means no fractions, no decimals. Okay, excuse me, moving on. Let me stop and make sure you can hear me. Can you hear me? Okay, so now we are at example 2. And remember what we need. We need a point and a slope to write the equation of a line. So here we have a line has a slope of negative 2/3. So we have the slope and it contains a point. There we go. And our point is at negative 3, 6. Well, this is not a y-intercept because your x is not 0. So find the equation of a line. So we could go to point slope form because what do we have? We have a point that's not an intercept and a slope. So that's one option. So I'm going to start there by using this is my m, this is my x sub 1, and this is my y sub 1. That's my point 1. So I can plug that into this equation here, this formula. So we're going to do y minus our y sub 1, which is 6, equals our slope, negative 2/3, times x minus our x sub 1, which is negative 3. I'm going to go ahead and change that. And now that is an equation of a line that is actually an acceptable equation of the line, but typically we would put this in slope-intercept form. So we'll go ahead and clean this up and put it in so we could write it as a function and we could graph it. So we're going to distribute. So we get y minus 6 equals negative 2/3 x minus 2. And if you're wondering how I did that so quickly, I just did negative 2/3 times 3. And then canceled the 3's. So there you go. All right, now all we have left to do to put this in slope-intercept is to add 6 to both sides. So I'm going to squeeze that in there and simplify that. So final answer would be y equals negative 2/3 x plus 4. All right, so that's one way to go about it. Now you could also take these pieces of information here, your slope and this point xy, and plug them into slope-intercept form, where you could plug the x into this position and the y into that position because this xy is actually on this equation. And you have those 3 pieces of information and you can solve it for b and find your y-intercept. So if you wanted to use, instead of point slope, which is what we did over here, you could use slope-intercept by doing this, right? You have y equals mx plus b. And so you would just take this y right here, 6, your slope, and then x, which is negative 3, plus b, and solve it for b. So here we have 6 equals, again, we're just simplifying that, to 2 plus b, that's a b, and then subtract 2, and you can see that b equals 4. All right, so there you have your equation. So you have your slope and you have your intercept, your y-intercept. So y equals negative 2/3 x, just plugging in your slope, and your b. So you will like one method over the other. Choose the one you like and stick with that. Okay, and then if I wanted you to put this in standard form, you would clear the fraction by multiplying everything times 3 and then putting the x in the front, just like we did with this last one. Okay, so I'm going to go get a highlighter real quick and go back and just highlight a couple things. So we have our equation there and our option here for point slope and our option here for slope-intercept. All right. Oh, wait, and I'll go back here and our option for standard form. These are all, like these first 2 equations here are the same equation, same line, and these 2 equations here are obviously the same line, just found in different manners. Okay, next. Find the equation of a line containing the points 2, 3, and 1, negative 4. So something you could do is sketch a graph and graph those 2 points and then find your slope by counting your rise and your run. That's up to you. Or you can use your formula for slope. So remember slope. Well, let me go back and get a pen here and arrow back and get rid of that. All right. So remember slope is change in y over change in x. Okay. And so remember that to write the equation of your line as well, I said you need a point, and I have two of them, and the slope, of which I don't have either. But I can find the rise and the run from those 2 points. So we're going to start by finding the slope, and I'm just going to subtract my x's. So -4 minus 3, change in y, over 1 minus 2, change in x. And so our slope is -7 over -1, or simplified -7. So there's our slope. So we know our slope is 7. And then either of these 2 points will work. I'm going to go ahead and just use the point 2, 3. And that will be my y sub 1 and my x sub 1. And I'm going to use point slope because that's my preference. You can use slope-intercept if you want. Here we can go our own way. But let's write the equation of this line in slope-intercept form at the end. So we're going to do y minus our y sub 1, which is 3, equals our slope times x minus our x sub 1, which is 2, and we'll multiply. And so I'm just going to bring this math up here. So we have y minus 3 equals 7x minus 14. Add 3 to both sides to isolate y, so it's in the function form, 7x minus 11. So your y-intercept is -11. So if I were to go graph this line, I bet I would find these 2 points on it. Let's go ahead and go look at that. So if I go, get out of there, we don't need to see that. Sorry about that. Bring this in the screen here. Let's go to Desmos. And we're just going to type in that equation. So it was y equals 7x plus 11, I believe. So we'll zoom there. And let me double check. Was it plus 11? Oh, it was minus 11. So sorry about that. We'll change that to minus 11. And let's see if those 2 points, so there's one -4. That was one of our points. And 2, 3 was another one of our points. So you can see there that both of those points are on that line. And that's a good way to check to make sure your math is correct. All right. Now, so we've talked about how to write equations when you're given information, whether you're given 2 points, you're given a point and the slope, or you're given the slope and the y-intercept. Those are your options. Okay. Now let's talk about some special lines. So first we have parallel lines. So there's 2 criteria in order for lines to be parallel. Okay. If 2 lines are vertical, right? So first, if 2 lines are vertical, they're parallel. As long as they have different x-intercepts. Okay, so remember that vertical lines are like x equals A and x equals B. Okay, so those would be 2 parallel lines. They're vertical lines. And we should just say that A cannot equal B. Okay, so as long as they have different x-intercepts, they will be parallel lines. The other one here is if you have non-vertical lines, so non-vertical lines will be parallel as long as they have the same slope. So they have the same slope, non-vertical lines that have same slope. Oops, we'll erase that real quick. I don't need to write have twice. Same slope, right? Same slope, but different. I was thinking of different having 2 F's and I wrote 2 B's. Not quite what I wanted to do. Same slope, but different. Wow, I'm having trouble. Different y-intercepts, right? One is going to be higher than the other. So parallel lines, those are your 2 criteria. If they're vertical lines, they're parallel as long as they have different x-intercepts. If they're non-vertical lines, whether they're horizontal lines or diagonal lines, if they have the same slope but different y-intercepts, then they're parallel. If they have the same slope and they have the same y-intercept, they're not called parallel lines, they're called coinciding lines, which means they're exactly the same line. All right, perpendicular lines. Perpendicular lines, now this is a really important. Two lines are perpendicular if and only if you have a vertical line and a horizontal line, right? Those, I'm going to make an ampersand here. And so a vertical line and horizontal line. So if you have a y equals a number, it will be parallel to an x equals a number. So those will be perpendicular lines because obviously vertical and horizontal lines intersect at 90 degrees. So remember that. Perpendicular means intersect at 90 degrees. Parallel means they have the same slope. Okay, so that's one test to know you have perpendicular lines. Or if their slopes are opposite reciprocals. If slopes are opposite, okay, that means that their signs change. One's positive and one's negative, and they are reciprocals. So a test for that, so opposite reciprocals. So like, for example, A over B will be perpendicular to the opposite B over A. So they have opposite signs and they're reciprocals. And a little test for that would be the slope of the first line times the slope of the second line will always equal -1. So that's a test. If you just multiply their slopes and it equals -1, they're perpendicular, unless they're vertical and horizontal lines, which is a special case there. So there's our parallel lines and our perpendicular lines. All right. So our last examples here say to determine whether each of the following pairs of lines is perpendicular, parallel, perpendicular, or neither. So what could you do to identify this? So what we could do with these two equations are somewhat in standard form here, so we can't really see the slope, is we can go ahead and put them both in slope-intercept form. So if I subtract 2, that gives me y equals 5x minus 2. So this has a slope of 5. Okay, let's move this one. We'll rearrange it. So we'll move the x to the other side, put it up front right here. So 5y equals -x minus 15. And then divide by 5, divide by 5, and divide by 5, and we'll simplify. So that's a y equals -1/5 x minus 3. So are those slopes? So that's a slope of -1/5. So we could just test it really quick. We can go, all right, 5 times -1/5. What does that equal? It's -1. And so these two lines, we could say, are perpendicular. So I'm just going to put a perpendicular symbol between them because their slopes are opposite reciprocals. So they are perpendicular. Okay, let's take a look at these next ones. So we have another equation here in standard form. We'll move the 4x over. So 2y equals, we're subtracting that 4x, so -4x plus 8. Divide by 2. We get y equals, for -4 divided by 2, -2x plus 4. So in that one, our slope is -2. In this one here, when we move this to the other side, actually, I think instead what I would just like to do, since the y is already pretty isolated, other than the -1, is I'm just going to divide everything by -1 and rearrange it so the y is over here. So that would be y equals -2x minus 5. So let's double check. So they both have a slope of -2, and they also have different y-intercepts. And so this one has a slope of -2 with different y-intercepts. And so I would say that those two lines are parallel. So that would be my solution for that. And then, sorry about that. Last one, C. So here we have, oops, let me go back and grab my pencil here. So here we have y equals 2x plus 1. So we have a slope of 2. And over here, if we subtract that 3x to the other side, we would have y equals -3x plus 4. And so that has a slope of -3. So this doesn't fit either criteria. So what this means is that these two lines are just going to be intersecting in some way. So this would be neither. Okay, last example here. It's asking you to think a bit more. Write equations of the line A parallel to and B perpendicular to the graph of the line 4y minus x equals 20 that contain the point 2, -3. So we're writing equations of two equations that are related to this line, parallel and perpendicular, so we need slope. And then they're passing through this point here. So this is going to be my x sub 1 and my y sub 1. So first let's find the slope of this line. So we're going to take 4y minus x equals 20, and we'll move the x to the other side. So we're going to add x. So that's going to be 4y equals x plus 20. And then we'll divide everything by 4 and simplify. So this is going to be y equals 1/4 x, right? If you take x and divide it by 4, you cut it in fourths, plus 5. So the slope of this line is 1/4. So over here, I'll do the parallel example, and over here, I'll do the perpendicular example. So perpendicular to 1/4 would be -4/1. So this will be our perpendicular slope. So we're going to use slope -4 and the point 2, -3. And over here, we're going to use parallel, so same slope. So we're going to do slope is 1/4 and point is 2, -3. So I'm going to start with this one here. And I think I'll plug this into point slope. So I'm going to do, because it's a point that's not a y-intercept, so y minus -3 equals my slope times x minus my x sub 1, which is 2. Clean that up a little bit with a change. Double negative makes a positive. So that's y plus 3 equals 1/4 x minus 2/4, which is 1/2. So that's a little bit annoying because we're going to have to move this 3 over here, but that's okay. We'll subtract 3 and subtract 3. So that gives us y equals 1/4 x. And then that would be 3 is the same as 6/2, right? 3 over 1, I could just go times 2 times 2, 6/2. So -1/2 minus 6/2 is -7/2. And so that would be the equation of the parallel line. So that's our parallel line. And over here, we'll do the same thing with our perpendicular line. So we're going to use the opposite reciprocal of 1/4, which is -4/1, or just -4. So we'll do y minus -3 times -4 times x minus 2. Clean it up and distribute. So y plus 3 equals -4x plus 8. Subtract 3, and we get y equals -4x plus 5. And this would be our perpendicular example. And there you go. So today you'll be doing some practice with problems like that. Writing equations of lines. Okay, so what information is needed? Point and a slope. And then, so you practice that and you choose the equation or the formula that you want to use to help you to do that. And then how can you tell if an equation represents a perpendicular or parallel line? You find the slope, and then you look at the slope. So make sure you review that. Now, there we go. If you need more practice working on converting from slope-intercept to standard form, I can provide you with that practice. Just let me know. Have a good day.